Hello and welcome to the first part of permutations and combinations. So first of all, let's go to the basics. So what is a factorial? A factorial is the product of an integer and the integers below it. So for example, 9 factorial will be 9 into 8 into 7 into 6 and so on till 1. So where are factorials basically used? Factorials are basically used when you have to arrange something. So for example, I want to arrange ABC. So there are number of possibilities that can happen. I can have ABC, I can have ACB, I can have BAC, I can have BCA, I can have CBA and CAB. So these are 1, 2, 3, 4, 5, 6 possible outcomes. But doing it this way, there's a chance that you miss one out. Okay, so an easier way is use 3 factorial, which is also equal to 6. So how does 3 factorial work? So basically there are 3 variables. So in the first, any of the 3 can fit, okay, either A or B or C. And then in the second one, the remaining 2, and then in the last one, the last one can fit. So any of the 3 into 2 into 1 will give us 6 outcomes. So this is how we determine the total number of outcomes using factorial. Okay, now what are selections? So they are the number of chosen variables in which the order does not matter. So for example, I have 1 girl and 2 boys. So I say I have to make a team of 1 girl and 1 boy. So there are only 2 possible outcomes: girl 1, boy 1, or girl 1, boy 2. Okay, these are the only 2 options. But if someone says, why don't you choose boy 1, girl 1? I'll say, okay, that is the same thing as this. So in order does not matter in some of these cases. Okay, now what are arrangements? Arrangements are in which the order does matter. So for example, we did ABC, so we can see that the order changes the word. So in some cases like these, the order matters. So basically these are permutations and these are combinations. Okay, now let's move forward to some basic questions. So let's take this first question as an example. Claire has to do the following things during her lunch break: take lunch, post a letter, go to the bank, or buy the afternoon papers. So again, these are 4 things which she can do in 4 factorial ways. That means that she can do it in 24 ways. So 4 into 3 into 2 into 1. So that will give you 24. Alright, similarly in the second question, 6 men and 5 women are available to form a mixed doubles pair for a tennis match. So there are 5 women and there are 6 men. So the first man can play with the first woman, with the second woman, with the third, with the fourth, with the fifth. The second play with the first, the second, the third, and so on. All of these can play with each other, can form a mixed team to play. So these are a total of 30 possible outcomes. Alright, so now we know that if something happens in succession, so we multiply the number of variables there are, so we can find the total number of outcomes. Okay, so now let's take a look at this history question. So this involves the word history. Okay, so 7 letter arrangements from the word history. Now, as all of the letters are different, none of them are same, so we can simply use 7 factorial, which is equals to 5040. Okay, so now that we have to use only 4 letters, so for this we use the formula C. So as there are 7 available letters and we have to choose 4, we will use 7C4 and put this in our calculator. So these are the number of selections for 4 letters, which are 35 out of 7. So we can have 37 combination of letters from these 7 letters, 4 letters combinations. Okay, now we have to arrange them as well. So as there are 4 letters, we will multiply it with 4 factorial and we'll get the answer 840. Okay, now it says 7 letter arrangements in which O and R are together. So in questions like these, what we basically do is we bundle O and R up as one character, and we say this is the first, the second, the third, the fourth, the fifth, and the sixth character. So we basically shuffle these 6 up in 6 factorial ways, and because O and R can also be written as R and O, so we shuffle these up in 2 factorial ways. Alright, so this gives us the answer of when O and R are always together. So this gives us the result 1440. Okay, now let's move to the next part of this question. Alright, so in this part it says 7 letter arrangement in which O and R are separate. Okay, now there are 2 methods of doing this one. The first method is that we have 7 letter arrangements without any restrictions. That means that it has both O and R which are separate and in both O and R which are together. Okay, now we have the 7 letter arrangements of which O and R are together as well. We just took it out, which was 6 factorial into 2 factorial, which gave us 1440. So basically if we subtract 1440 from 5040, we'll get the number of arrangements in which O and R are separate. So this equals to 3600. Okay, now the second method is that for a second we forget O and R. We take the other letters H, I, S, T and Y. So we have this 1, 2, 3, 4, 5 characters, and we can shuffle these up in 5 factorial ways. Okay, now we have this 1, 2, 3, 4, 5, 6 places. If we place one letter over here and one letter over here, then these both will be separate. Or if we place one letter here or the other in any other box or any other combination of these 2 letters, so that will make us make O and R separate. So as there are 6 places, the first letter can go in any of the 6 places and the other letter can go in any of the 5 other places. That will also give us 3600, confirming that O and R separate have 3600 combinations. Okay, now let's take a look at this question. How many digits between 2000 and 5000 can be made from the digits 1, 2, 4, 5, 7 and 8? So for it to be between 2000 and 5000, it has to be a 4-digit number. So for it to be between 2000 and 5000, it can only have 2 and 4 as the first letter. So any of the 2. Now we are left with 1, 2, 3 and 4. So any of the 4 can go in the second number. Now the remaining 3 can go in this one and the remaining 2 in this one. So basically we have a total of 48 possible numbers which can occur from these letters between 2000 and 5000. Okay, now let's take a look at this question. It says that 9 different books are to be arranged of a bookshelf. 4 of these are by Shakespeare, 2 by Dickens and 3 by Conrad. Okay, how many possible permutations means arrangements are there if the book by Conrad must be kept next to each other? Okay, so we've done a question similar to this. So in the first part, we'll just consider the books of Conrad as one. So we have 1, 2, 3, 4, 5, 6, 7, 8 and 9 books. Okay, 4 of them are by Shakespeare, 2 of them are by Dickens and 3 of them are by Conrad. Okay, so we'll consider these as 1 and 1, 2, 3, 4, 5, 6 and 7. So 7 factorial into 3 factorial, because these 3 books can be shuffled amongst themselves. So 7 factorial into 3 factorial will give us the number of arranged books we can have if cornered books are kept next to each other. So this gives us 30,240. Okay, now in the second part, it says that the books by Dickens are separated from each other. So we did 2 methods for this. I'm going to do the second one. So let's not consider the book of Dickens, and let's take these 7 books right now. So we can have 7 factorial ways in which we can arrange all of these. And then we have 1, 2, 3, 4, 5, 6, 7 and 8 places. So we can have the first one in any of the 8 places and then the other one in any of the 7 places. So this will give us 282, 240. Okay, now let's take a look at the third part. So the third part is similar to the second one. The books of cornered are separated from each other. Okay, so if we consider the other books and forget the books of cornered for a second, these are 1, 2, 3, 4, 5, 6 books which can be shuffled in 6 factorial ways, and then 1, 2, 3, 4, 5, 6, 7 spaces. The first book of cornered can come in any of the 7, the other in any of the 6, and then the last one in any of the 5. So this will give us 151, 200. Okay, so we're done with the first part of permutations and combinations. See you in the next video. Goodbye.